Well, this video is for Math 112, and this is for section 2.3. And so we're going to add another wrinkle to our discussion of graphing trigonometric functions. This one is frequently called vertical shift or vertical displacement. So the concept here is, I'll use the example that's on page 73 in the textbook, where we look at a standard sine function. Let's see here. There's 1 and -1. Something like that. I think I missed the minimum value there by a little bit, so it'll be more like that. Okay. So that's y equals sine x. Now, if we had, in the textbook I use 5 plus sine x. But typically the way that these are expressed is sine x plus 5. Now, in the next section, section 2.4, we'll be looking at things like y equals the sine of x plus pi, which is different from this, right? So if I'm going to include something inside what's called the argument of the sine function, right? Because whatever's inside here, we take the sine of that and then do something else to it. Here, we take the sine of x, and then after that, we add 5 to it. Here, we take x, add pi, and then take the sine of it. So that's an important distinction. If you don't see parentheses here, then these are not together. Okay, they're separate. All right, so what does that do? It adds 5 to all of the y values. So instead of this being 0, now it's 5. Instead of this being 1, now it's 6. And then 5, and then instead of -1, we'll have 4. And then back up to 5. And so it'll have the same shape, it'll have the same x values along here, but everything gets pushed up by 5 places. Now frequently what people do, and I do this as well, is to just draw the graph like this with the 5 at that center line, and then look at the amplitude. In this case, the amplitude is 1, so we go up 1 and down 1, and then we sketch our x values for the quadrantal values that produce the 0 maximum, 0 minimum, back to 0. And so there's a sketch of y equals sine x plus 5. So that's the major concept for this idea of vertical shift or vertical displacement. Now that's, we'll look at some example problems in a few minutes, but I also want to talk about going in the opposite direction. So if we've got a graph, let's see here. And I'm going to draw this a little bit differently than the way it's drawn in the textbook, although it is kind of hard to tell here. Yeah, so this is 2, and it goes up to 6, and down to -2, and our period here is 3 pi. 6 pi over 4, 9 pi over 4, right? Yeah, okay. And so it goes up here, 0, minimum, back to 0. Okay, so there's the example. This is on page 75. And the idea is that we want to write an equation that represents this graph. And this is sort of similar to what we'll see in the second project. In the second project, you'll have some information about the period of some phenomena, a maximum value, a minimum value, and so this can help you to write an equation to model that situation. okay? So let's see here. We've got to, well, we're going to write this as a sine function. So a sine bx plus d. In section 2.4, we'll put a c inside here and see what that does to our function. So let's see here. So what's been shifted? Well, it's been pushed up 2 places, okay? That's what this midline being at 2 is telling us. Instead of being at 0, well, that's the 0 on the x-axis, okay? The 0 on the y-axis is over here. All right. So this has been pushed up 2 places. That tells us that our vertical shift here is going to be 2. Now, the distance between this, what's sometimes called the midline value, and the maximum value, that's 4. And this is also 4. The difference between the midline value and the minimum value is also 4. That says our amplitude is equal to 4. Okay? There's a formula in the textbook that I mentioned that you can use to calculate this, and that is to take the average of, let's see here. To find D, you take your max plus the min and divide by 2. So in this case, that would be 6 plus -2 divided by 2. And there's our value for D. Okay? The amplitude is the difference, or the total distance here, between the maximum and minimum. So this is max minus min divided by 2. And so in this case, that's 6 minus -2 over 2, which is 8 over 2, which is 4. And that's the value for A. So I just talked about an intuitive way to find the values for D and A, and 2 formulas that you can use to find the values for D and A. All right. Now we just need to find the value for B. Remember, the period is 2 pi divided by B. So B is 2 pi divided by the period. In this case, that period is 3 pi. The pi's cancel out. And B is 2/3. And there's our equation. Okay? All right. Let's look at some problems. Go over some problems. The first half will be graphing problems. And the second half will give you a graph and ask you for an equation. So let's see, I'll put these little formulas up here. D is the average of the max and the min. A is the distance between the max and the min divided by 2, or half the distance between the maximum and minimum values. Okay. So, on page 77, we've got a set of problems to look at, so we want to sketch graphs for these. Problem 2, y equals cosine x minus 1. It's a standard cosine function, so it's going to have a period of 2 pi, and these are going to be the standard values for the quadrantal angles, pi over 2 pi, 3 pi over 2, and 2 pi. It has been shifted down by 1 place, but our amplitude is still 1. Okay? So the midline will be at -1, and then the amplitude will make it go up 1 to the maximum, down 1 to the minimum, and those y values will be 0 and -2. All right, so this is a cosine function, so it starts at the maximum, 0, minimum, 0, maximum, and there's a sketch for number 2. All right, problem 4, we've got 5 sine x plus 4. Okay, so our midline value is going to be at 4. Our period is still 2 pi. Okay? Now there will come a time when I throw all of this into a single problem at once. Okay, but for right now, noticing I'm not messing with the period too much. We will get into that as these problems move on. All right, let's see here. So now the amplitude here is 5. That says the maximum is going to go up to 9. The minimum is going to be down at -1. Okay. Let's see here. This is a sine function, so it starts at the midline value, goes up to the maximum, midline, 0, midline. I sometimes call that midline the 0 because in the standard sine and cosine functions it is 0, but that's an equivalent. To me, it's equivalent to say 0 or midline. Okay, it just helps to define the shape of the trigonometric function. All right, so I think that's good for number 4. Now we'll get into one that has a different period instead of 2 pi. All right, problem 6. Y equals negative cosine 2x plus 7. Now, before I do this one, I just want to mention I just got done making some quizzes for section 2.2. Now, in the textbook, I'm asking you to sketch these graphs. Using my Open Math website, it's very, very difficult to get a good quiz question where I ask you to sketch a graph. Okay? But I want you to know that just because I haven't put that on the My Open Math website doesn't mean that you're not going to be asked to do that on the midterm and on the final. Okay? It's very important that you understand that I'm going to be asking you to sketch these things on the test papers. Okay? Let's see. What else? Oh, I think there was something else I wanted to say about that. Can't remember exactly what. Oh, it was the sample midterm. Before the midterm, I'll post a sample midterm exam. I'll make a video of myself going over it, and you'll see those questions where I ask you to sketch these graphs. It's very important that you understand how to do that. On the My Open Math quizzes, I'm just going to sort of ask you questions that get at that same knowledge without requesting you to sketch one on a piece of paper. So I did want to mention that because I don't want people to get the wrong idea that just because you don't see these problems on the My Open Math quiz, that's not to say that you're not going to be asked to do them on the midterm and on the final, because you will. All right, so here's our midline value, here's our vertical shift, +7. Our amplitude here is 1, so the maximum will be 8 and the minimum will be 6. All right, along the x-axis, now we've got a different period. Our period is 2 pi divided by b. So our period is a distance of pi, and we need to chop this up into 4 pieces. Okay? So this middle one is the period divided by 2. This one is the period divided by 4, or the middle divided by 2. And so this is 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4 is right there. Okay, so looks like we've got everything set up now. Now, last thing I want to mention is this is a negative cosine. So instead of starting at the maximum, it's going to be flipped around. It's going to start at the minimum. And then it'll go through the midline, up to the maximum, back to the midline, and then back to the minimum. And there's number 6. All right, let's keep working on these. Problem 8. Let's see here. -1/2 cosine 2 pi x plus 2. All right, let's see here. So that means it's going to go up to 2.5 and down to 1.5. Okay. All right. So there's those places. Let's see. What else do we need? We need the x-axis. So the period is going to be 2 pi divided by 2 pi. That's the value of b in this problem is 2 pi. Anything that's not x is b. All right? So that says our period is 1. Divided in half. Divided in half again. 1/4, 2/4, 3/4, and 1. And again, notice that if you have pi as part of your value of b, you won't have it along the x-axis. If you don't have pi along with your value of b, you'll have pi in your x-coordinates. All right, well, now that we've got that done, looks like it's time to draw the graph. Again, this is a negative cosine graph. Starts at the minimum value, midline, maximum, midline, back to the minimum. And so it'll look something like this. Okay, got a couple more here to look at. Let's see what else we've got. Let's see, problem 10. Y equals 4 sine 1/3 x minus 1. Okay, so that makes our midline value there -1. Let's see, our amplitude is 4, so this will go up to 3 and down to -5. And we'll put our period markers in here. The period is 2 pi divided by 1/3. That's 2 pi times 3/1, or 6 pi is the period. Okay, so half of that is 3 pi, half of that is 3 pi over 2. So 3 pi over 2, 6 pi over 2, 9 pi over 2, and 12 pi over 2. Those are our critical values along the x-axis. There's our 0 on the x-axis. So this is a positive sine function. It starts at the midline value, goes maximum, midline, minimum, back to the midline. Graph looks something like that. Good. Let's see here. Well, let's do number 14. It's written in a little bit different format. 5 minus 3 sine 2x. Well, just because this is in the front and not in the back doesn't change anything. This is the value of d. Okay? That's our midline value, +5. Let's see, the amplitude is the absolute value of this. It's 3, so it's going to go up to 8 as a maximum and down to 2 as a minimum. All right, now that we've got that set, our period is 2 pi divided by b. So that's just going to be pi. That'll be pi over 2, pi over 4, and 3 pi over 4. Now the last thing to point out before I go and draw the sine function is, again, this is a negative sine function. So it's still going to start at the midline value, but it's going to go down to the minimum first before it goes back up to the maximum, and so it ends up looking like that. Okay, so that's the first half of the assignment. You get the equation, and I ask you to draw a graph, and again, you will see that on the midterm, and you will see that on the final exam. I can't find a good way to do that on the My Open Math website, unfortunately. All right, let's see here. Now, in the next set, we've got 3 problems, 3 odds and 3 evens. And we've got a graph. And I'm going to draw the graph the same way that I was doing them for problems 2 through 14. So I'm just going to label this midline value as -4. Looks like we've got a maximum at -1, which should put the minimum down at -7. It's kind of difficult to tell because the tick marks are labeled every 2, but it's pretty clear that that looks like it's not stopping at -2. It is going up to -1 there. All right, and the period here is pi. Okay, well that's good. And our graph looks something like this, a standard sine function. Okay? All right, so well, we've at least identified that. We've got a sine function. It's a positive sine function, and the amplitude here is 3. So again, intuitively, you can look at this and say, oh, this goes up 3 from -4 to -1, and it goes down 3 from -4 to -7. That means the amplitude must be 3. You can also take the max, sorry, I'm doing A. We can take the max and the min, -1 minus -7 divided by 2, and that'll calculate the value of A. Now, again, there's no silver bullet for getting these answers right. There's always a trap to fall into, okay? You may get confused by how this works. You may get confused by all the negative signs. Like I said, there's no silver bullet. That's why I think it's really helpful to think about this both intuitively and in terms of a formula, and so then you can compare them against each other and check yourself. Okay? I mean, that's what I do constantly because I frequently don't have an answer key for problems that I make up or problems that I want to assign. I've got to make the answer key, then I've got to make sure that those answers are right. Okay? And the best way that I know to do that is to do the problem different ways, see if I keep getting the same answer. Okay? So that's something I want to point out to this idea of the intuitive approach versus the formula approach. Whichever one you think is most helpful to you, then by all means go ahead and use that. But be aware that neither is foolproof to preventing human error. All right, let's see here. So there's our value for A. We know our shift is right here. It's -4. Okay, so I'll just put an empty parentheses, and then I'll put the -4 on there. Now we need to know the period. Okay, so at this point, we've done a bunch of these before where the period is pi. That says the B is going to be 2, but we can calculate that. Okay? Again, we can think about it intuitively, or we can use a formula. The period is 2 pi over B, so B is 2 pi over the period. In this case, the period is pi, and B is equal to 2. And there we go. There's our equation. Y equals 3 sine of 2x minus 4. All right, that's problem 16. Problem 18. Okay. So this is one where I've drawn the midline value along here. This is -3. The maximum is -2. The minimum should be -4. Yep. And our period is 2 pi. That says B is going to be 1. Okay, great. So let's see here. Now again, notice this is a cosine graph. Looks something like this. It starts at the maximum value, so this is going to be a cosine graph. It's a positive cosine graph. Let's see here. The vertical shift is going to be -3. Our amplitude is just 1, right? From the distance between each of these. This is 1, this is 1. And so you can put a 1 out in front here, or you can just leave it blank. That's up to you. And same thing inside here. Our period is 2 pi. So B is 2 pi over 2 pi, which is 1. So you can call it 1x, or you can just say y equals cosine x minus 3. Either one of these is correct. There's nothing wrong with either one. Okay, let's look at one more. Problem 20. Problem 20, again I've got the midline value here at -1, and then it goes up to +1 and down to -3. So that's telling me that amplitude looks like it's going to be 2, right? Let's see, our period goes out to 8 pi over 3. Okay, that means that should be 4 pi over 3, right? Yep. And then that'll be 2 pi over 3, 2 pi over 3, 4 pi over 3, 6 pi over 3 is 2 pi, and then there's our 8 pi over 3. And let's see, and this starts down here, goes through the midline, and comes back, something like that. Okay, let's see. So, this is a cosine graph because it starts at the maximum or minimum rather than the midline. Okay, and the fact, well, let's put the vertical shift in first. That's going to be -1. Our amplitude, I mentioned, is 2. Okay, so you can do 1 minus -3 over 2, and that's 2. But again, this is a negative cosine graph because it starts at the minimum rather than the maximum. Okay, now finding b is going to be a little bit tricky. This one I'm going to use the formula because it's a little bit tricky to just look at this and know what the value of b would be. Let's see, 2 pi divided by the period, which is 8 pi over 3. So 2 pi times 3 over 8 pi. The pi's cancel. 2 goes into 8 4 times. 3/4. 3/4 x. There we go. -2 cosine 3/4 x minus 1. All right. So that's it for section 2.3. We've got one more concept to talk about in graphing, and that will push the starting points and ending points back and forth along the x-axis. That is kind of a tricky thing, and so I will make a video for that in the next couple days. And then there's one more section in chapter 2 where it's just extra practice sketching these graphs. As always, if you have any questions about this, please let me know. Thanks.